Have you ever wondered how transparency is handled inside your browser and other photo editing or image viewing softwares? Well, so let's say, for example, I have this image over here, right? And uh, the background of this image is transparent, and the browser represents it as um, grayish cells, right? White and grayish cells. Okay, but how does it do that, right? How does it know that a particular pixel has to be shown transparent, right? And well, the answer for that is, so to basically understand that answer, first thing you should understand is that all PNG images, they can basically be represented as a 2D array of values, right? And what are those values? So RGB and A, red, green, blue, and alpha, right? RGB are the primary colors from which all other colors can be made. They are the foundation of color theory. And alpha over here represents the opacity or the transparency, right? So what they do is they basically set the opacity value of the pixels that they want to be transparent to be zero. So they have no opacity, right? That signals that they must not be displayed or they are to be displayed transparently. Okay, but so that's how it works on a higher level, right? Now let's like dive deeper and understand how it works on a lower level. So over here, what I have is a simple OpenGL application, so you don't have to worry about it. This is basically just an application which technically just uh, reads this PNG file, this the same PNG file that I showed you over here, and just renders that texture onto a 2D surface, right? In this case, a square. So if I run it, this is what we get, right? One thing you can notice over here is that the transparency is already gone. Right? Now, why is it gone? The thing is that any software, right? Any graphical software, any image editor, or you know, any image viewing module of any browser, they don't really just handle transparency by default. You have to explicitly tell the graphics API or your GPU how to handle transparency. So the thing over here is that this image or this texture that you're trying to draw over here is one layer, and the background behind it is another layer, right? So only if there was a way to tell how to mix the colors, uh, pixels, right, that are present in my first layer and my second layer, then I can make this transparent, right? So imagine this: if there was a way I could tell that all of the pixels in my image that have a opacity value of zero, right, just make that color so the final pixel that is going to appear on the screen for that those pixels which have an opacity value of zero, that resultant pixel should have the same color value as the background, right? Again, to summarize, what I mean is that only if I had a way to say that, okay, uh, in my source pixels, so this the pixels associated with this image, if they have an opacity value of zero, so the final pixel that has to be rendered onto the screen, just make that color of the final pixel to be the same as the pixel color of the background, right? If I could do that, then 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 this image would be turned transparent, right? And this entire process of mixing colors is known as blending. And we can do this simply, very simply in OpenGL. What we can do is just specify a blending rule. First of all, we have to enable blending by this simple GL call, GL enable GL blend. Then we have to provide a blending function, right? Now, I won't go over the details here, but this simply is doing something known as a alpha blending, right? And if I just show you the result over here, okay, so now the image is completely transparent, right? I will just go into small details of what's happening over here. So alpha blending is going on over here, right? So what it's saying is that you have a color source, right, or a source color, and you have a destination color, right? Um, and you have another two values, the source multiplier value and the destination multiplier value, right? So the arguments that I'm specifying over here, this is GL source alpha, which basically means that multiply the source by alpha, which is the opacity, and the second argument is 1 minus source alpha. So multiply the destination pixel by 1 minus the source alpha. So what's happening over here is that the source image, all the pixels which have an opacity of 0, they would be multiplied by 0, right? Their color would be multiplied by 0 according to this formula. So SRC over here is 0, right? So this whole term would become 0. And destination over here would become like 1 minus 0, which is 1, right? And so it would become color destination times 1. So the resultant color would be color destination. So the final color that you get onto the screen, it would be the same as the destination color for the pixels that are completely opaque. For the pixels that are completely transparent. So this is how transparency is handled inside images. Thank you.